Here's a video for 5.1.4 multiplying mixed numbers. And you can just see some examples of mixed numbers right there. 1 1/2, 3 5/6, 7 1/8, 5 1/3. I'm going to do a couple of quick review problems before I dive into our goal today. Just as a little reminder, when we multiply fractions, we multiply our numerator. So this is 3 times 5, and this is 4 times 7, right? Those are denominators. 3 times 5 is 15, 4 times 7 is 28, okay? Sometimes we also get problems where we multiply our numerators. 2 times 5 is 10, 3 times 6 is 18, and we do need to reduce. So don't forget that sometimes we need to do that, and in this case we can divide both of them by 2, and I'm going to get 5/9. I also want to review a little something about multiplying whole numbers times a fraction. Keep in mind that this 4 is 4 1-whole units, so I can write this as 4 ones. This really helps me when I'm trying to multiply fractions, because now I have a numerator and a denominator when I'm trying to multiply 4, right? So in the numerator I get 12, 4 times 3, which is 12, and then 1 times 5, which is 5. We could also rewrite that if we had to as 2 and 2/5. And lastly, just as one last show here, we could rewrite this as 5/6, but then we need to change that to a fraction to help us do that, and we'd write that as 5 ones, 5/1. 5 times 5 is 25, and 6 times 1 is 6. We could write this as 4 1/6. Okay, now let's get into the lesson today. Jules is a champion long-distance runner. He has measured the length of his route through a park and found that it is 4 3/5 mile long. Today he ran his route 2 2/3 times before he had to stop to rest. He wants to know how many miles he ran. So I just drew a picture of a park. And you can picture if you would go along that black line, that would be 4 3/5 of a mile. And he goes 2 2/3 around. So if you could picture him maybe starting in a certain spot and going 1, 2 2/3. The question is, when he stopped there or whatever, how far did he go, right? That's what we're curious about. So what's a way for us to do this? Well, sometimes you could think about it as going around and saying 4 3/5 plus 4 3/5 plus a piece of this, right? But when we have repeated addition, we always like to use multiplication. So what we're going to do is we're going to work on multiplying that 4 3/5 times 2 2/3. Now, we haven't done this yet, right, to multiply these, and that's what we're going to dive into right now. So what we're going to do is we're going to use generic rectangles to multiply this. Very much like if you look on the right, 45 times 57, 45 can be 40 plus 5, and 57 can be 50 plus 7. We're going to break these two pieces down, and we're going to do this 2 2/3. We'll write as 2 plus 2/3. And we're going to do the same thing to 4 3/5. 4 plus 3/5. And we will now multiply. And this is why we practiced all of that stuff up above, right? 4 times 2, the area of the upper left hand is 4 times 2, which is 8. In the upper right hand corner, I'm going to do 4 over 1 times 2/3, and that becomes 8/3. Then we're going to go to the lower left, and that one's going to be 3/5 times 2 over 1, which will be 6/5. And then in the lower right-hand corner, we'll have 3/5 times 2/3, and that will become 6/15. Whoops. Now if we look here, we have in the upper left, we have an 8, upper right 8/3, lower left 6/5, and lower right 6/15. One of the things you might want to do, or first thing you might want to do, is like with the 6/15, reduce it. In this case, I would be patient. Don't reduce yet. It might be helpful to keep it like that until we're done, okay? So we have our 4 pieces, and we need to add those 4 pieces. I wrote them all down here. 8, 8/3, 6/5, and 6/15. And what I'm going to recommend is now is a good time to rewrite these as whole numbers, as mixed numbers. I'll write 8 as 8, 8/3 as 2 and 2/3. We've been practicing this, so this should not be too difficult. We would write 6/5 and 1 and 1/5, and we would write 6/15 as 6/15. Again, don't reduce yet. The next step I would suggest is finding a common denominator. So we need to multiply by some giant ones. We don't, the only thing I need to focus on right here would be these fractions, right? I need to make those common denominators. And with all of the practice that we've been doing with that, I'd like to think that we can recognize that it is 15 as our best denominator. That's why I don't want you to reduce the 6/15, because you need to make it that anyway. So the giant 1 for the 2/3 will be 5/5, and the giant 1 for 1/5 will be 3/3. And we'll rewrite all of those. We're getting close here. We'll rewrite all of those now, and I'm going to line this all up as 8 equals 2 and 10/15. This will equal 1 and 3/15. And last, we'll have 0 and 6/15. We'll add up all of our pieces. 10/15 plus 3/15 is 13/15. 13/15 plus 6/15 is 19/15. 8 plus 2 plus 1 is 11. So we have 11 and 19/15. Boy, this is still a messy little deal. We have one last part. We can rewrite that little piece, right? If I just rewrite that part over here, just think about this for a second. The 19/15, that's not very bright. I should choose a little bit brighter color. Sorry about that. Let's choose green here. 19/15, that can be rewritten as 1 and 4/15. And when I combine 1 and 4/15 with my original 11, this will become 11 plus 1 and 4/15, which is a grand total of 12 and 4/15. Okay, so to make a long story short, right, how many miles did he run? 12 and 4/15 of a mile. And we use generic rectangles to help us solve this. Use our knowledge of previous generic rectangles, like we do here, to help us with that stuff on the left. And then we got to do some adding. Some problems are nicer than this. Sometimes they're not as nice as this one. It depends on how everything works out. And then I just wrote this quick summary. When multiplying mixed numbers, set up a generic rectangle, multiply the whole numbers and fractions, add all the areas, mixed numbers, common denominators, and simplify. If you have any other questions, please ask your teacher. Have a great day.